Hello and welcome back to math class. Here are a couple of calculus problems on a Monday afternoon. Differentiate something. Well, we can start this by applying the power of a function rule. We'll go 5 times all of this to the 4 times the derivative in here. That will be our approach. Power of a function rule. So it will be 5 times all of this to the 4 times the derivative in there. And the derivative in there will be a quotient rule. So it'll be top thing prime minus 2x times the bottom thing minus the bottom thing prime, which is 2x, times the top thing in brackets, all over the square of the denominator. And so here's the derivative. And we can factor this and simplify it. We look at the numerator on this factor and see that they both have a minus 2x in both the terms, so we could common factor that out. Take out the minus 2x, leaving behind 1 plus x squared plus 1 minus x squared, because I took out the negative 2x, leaving behind this plus sign. You can check the work by multiplying it back in. We got the minus 2x times this, and we got the minus 2x times this. And so that's all that happened here. And if we notice inside the square brackets, 1 plus x squared plus 1 minus x squared is the number 2. And 2 times this 2 is 4. And so we got minus 4x here in the numerator. Everything else is the same. Now what will happen is the minus 4x will come join with this 5, and it will become minus 20x. And the numerator will be 1 minus x squared to the 4. And the denominator will be 1 plus x squared to the 4 plus 2, which is 6. And that's the derivative of this function, which is a quotient raised to a power. And that's just good, a little bit of exercise in differentiating. Let's do some graph concept type question. The tangent to the cubic function, y equals x cubed minus 6x squared plus 8x, at some point a, 3 minus 3, intersects the curve. So the tangent goes by and touches the first function at 3 minus 3 and keeps going and intersects that curve again, because the curve bends back around to intersect the line a second time at point B. Find the second point and make a sketch. Solution: first, we can confirm that the point A is indeed on the curve. So we can do that by plugging a 3 in for x here, working it out, and y does turn out to be minus 3. So roughly, we have the situation in the diagram. Here's the cubic curve, there's the point A, and here's the tangent at A, and we seek the point B. This is the method you can use for such questions. Find the equation of the tangent to the curve at point A. So it's a typical calculus question. Find the equation of the tangent to the curve at point A, and once you've done that, set that equal to the equation of the curve. Because when two functions intersect, their y values are equal. So that's our plan then. Find the equation of the tangent to the curve at the point. Here we go, finding the equation of the tangent. There's the function, there's the derivative. Sub the x value in from point A, that'll give us a slope, m. Subbing in 3, because that was the point A. And 3 squared times 3 minus 12 times 3 plus 8 is negative 1. So we have our slope. And use y equals mx plus b and our point A. Plug them in to y equals mx plus b, including the slope, and we get y equals mx plus b. Doing the math, b turns out to be 0. So the y-intercept of the line is 0. So the line goes through the origin. Mine misses on the diagram just by a bit. The equation of the tangent is y equals negative x. Now we have our equations of the tangent. Both the line and the curve go through the origin because it's unlike what I've shown here. B is actually the origin. So we can see the blue line goes through the origin. The tangent must go through the origin because its equation is y equals negative x. So we can confirm that they do in fact meet at the origin by setting their y values equal to each other. We've got the curve, we've got the tangent, set the y values equal to each other, and the rest is, well, trivial. Move the minus x across, add it, makes it 9x, factor out the x, factor a trinomial, and we can see from our result here that x must be 0 or 3. When this curve and this line meets, x must be 0 or 3. Well, we already knew that they met at 3, and now we know that they meet at 0. And so the point B is the origin.